Yeah.
I will go ahead and get started.
Yeah. I would introduce you, but you're acting as in a personal capacity, so I'll let you introduce yourself.
Sure. All right. Hey, everyone. I'm Milas. We're going to talk today about getting Talos on a new single board computer, in particular the Radxa Rock 5, which I'll give you a quick overview of that device and sort of why I was interested in it. Before we jump into it, you might have noticed by my sweatshirt, I'm a software engineer at Docker. This is all just my own personal nonsense. I'll give you that up front. Any terrible practices that you start to see, you can just blame me. And secondly, if you actually come out of this and for some reason see all of my spaghetti hacks and decide I really want to run this, everything is on GitHub. For each Talos release, GitHub Actions does produce flashable images just like Talos, and you can use Talos Kettle Upgrade on the Rock 5. So as an end user, the experience is hopefully the exact same as normal Talos, but behind the scenes, there are some sketchy things going on, maybe, depending on your thoughts of, embedded hardware. So let's, I guess, back up a second though and just talk about how did I even get myself into this mess that we're about to look at. And really, I think this kind of goes back a couple years. I really like playing online multiplayer cooperative games. Something about the social aspect and just I think the modern day thrill of port forwarding is apparently my thing. So like many people in the heat of the pandemic, started playing a game called Valheim. If you don't know it, it's not really important. It's an indie open world crafting survival game. And so one of my friends set up a dedicated server running in a Docker container on his laptop. So that was great. We had a server. Everything was going wonderful until the first time that an upgrade happened and we lost all the save game data. So did a little bit of, a blameless postmortem, all the right things, and found out the root cause was actually that there was a case sensitivity issue on a file path for the save game. So even though there was a Docker volume behind the scenes, if you don't put the file in the Docker volume, it won't save you. So I also want to clarify that I was not involved in the sysadmin role at this point in time, but I still received the fault due to my container expertise. So as a result, I said, all right, we're re-engineering from first principles. We're going to cloud. We're going to Kubernetes. So that's sort of how I got into this. If you are sitting here thinking, wait a second, video games are historically not even Linux friendly for dedicated servers, much less ARM64. You are correct. There is an entire interim phase of this project at which I was in Linode and hosting there before deciding I wanted a lower power in-home lab and have since been migrating over as part of this project. So let's take a look at the Radxa Rock 5. I've got a physical one here. This is my test one. I was actually going to set up a cluster on it at the end of this, and unfortunately, it is no longer, this board in particular stopped booting on me last night, and I have yet to figure out if I shorted something out or what I did. So unfortunately, I cannot give you a live demo of spinning up a new cluster, but it's a little bit bigger than a Raspberry Pi. I've got some specs on the screen here. If you're into that, the kind of maybe useful thing at a high level is that it's got 8 cores and it's big little, which is common in ARM. So you have the 7 series cores that are more powerful and then the 5 series that are lower powered. And the ones that are on this board are actually pretty modern by ARM standards. There's a whole weird, thing there about how long it takes hardware, especially as a home end user, to become available. So this is a pretty exciting board because it's substantially more powerful. Benchmark it yourself, but I think the kind of the CPU number that gets thrown around a lot is about 3x the speed of like a Pi 4. So that's why I was really excited because it was kind of the first board I saw that was substantially more powerful from a low-powered ARM board that I thought could be really useful for kind of a bigger type of cluster. You also get some great RAM options. I have the 16 gig models just because why not? Lots of apps like to take up RAM. You can get fast storage, fast Ethernet if you're into that. And there's some other cool hardware on here. It's got an NPU for machine learning stuff. The deeper you go, the less documentation you're going to get, I'll be honest. But it's a very cool board. So what's the catch here, right? All right, I'm not an embedded or hardware developer. I am an Android user. I've done the custom ROM circuit back in the day, so I kind of know how the sausage is made. Um, you know, basically, it's not uncommon for when a chipset comes out that the manufacturer will have a kernel version that they kind of maintain. It's often called a BSP kernel for board support, and which is a maybe a forked off version of the Linux kernel, hopefully an LTS, that they maintain, but you might never get a major update. And there are often binary blob components in here for some parts, so you can end up in trouble. Um, so as an outsider to this world, other than kind of Raspberry Pis, it looks like the situation's been getting a lot better in recent years. But I would still, it's something to be aware of and kind of understand what your use case is, because you're not necessarily, especially today when this board has been out for under 6 months, not going to be running a mainline kernel. I do want to give a shout out to Radxa here. I think they get a lot of unfair blame in the process. They've been doing a lot of work. You're going to see some crazy diagrams. It can get overwhelming with the sheer number of Git repos and forks that are going on to kind of pull this together. But they have really been making this usable. They have a wiki that's great. They have guides and the docs. They put up the data sheets. They're really getting everything they can public and supported. So again, I think this is helping. And there is a community, there's a forum and a Discord, and so they're pretty active there, which is definitely helpful as well. And Rockship also has a lot of public documentation. I think they've historically kind of gotten some flack for this, but even compared to some other manufacturers, they have a wiki. I spent many hours looking at one of the pages about boot options and partitions. It was very helpful. So all right, enough rambling. Let's ramble about single board computers and Talos specifically. So SBC, you'll see a lot. It's single board computer, means Raspberry Pi, really kind of any of these type of boards is the classification. So let's talk about the normal way. This is not what I did, but there's reasons we'll get into. But let's talk about if you have a new board, where you would start. So in Talos, it's pretty great. We've got a nice directory with all of our boards. So you can pretty much make a new one and copy and paste and start from one of the existing ones. That's what I did. You'll see actually in this list, well, I have Rock 5B because I ran this command in my fork, but there's other Rock series devices from Radxa even in here that are also Rock chip based. So even if you're in a slightly unstandard situation, the Talos repo has a lot of good examples that cover the basis to get you started. From there, we really just have to implement this one interface, which more or less, again, copy paste, change some stuff as needed. The install is used if you're copying in something, custom type of thing. You can set some kernel args and type of things, but it's pretty straightforward to get everything up and running from the first time. And then I didn't go into it here, but the Talos make scripts, make it very easy to basically get out the .img or build a Docker image for upgrades. So that's definitely great. If you do have a custom kernel or custom U-boot, those are also possible. There's a couple of the boards in there already. I think the Jetson Nano has a custom U-boot, and then custom kernel is a fairly common process even for non-SBC. So it's really well supported by the Talos toolchain. But those are the other things because there's always more beyond the nice thing. So great. We're just moving along because now we're into the fun stuff, right? I hope, right? So let's do it the hard way. And I think we're going to start off. Let's make a list of what we need. So we just said, all right, we need our kernel, we need our U-boot. Did I mention that the U-boot doesn't support UEFI and Talos uses UEFI? So all right, let's go one thing at a time here. Let's start off with our build. So here again, I've got a nice little screenshot that is partially off the screen from the Radxa wiki. You can see that they have a nice, I've clipped to the main command to make the kernel, but again, they have wrapped up all the kind of packaging across these different pieces. But I wanted it in containers and GitHub Actions because I wanted everything to be as automatic as possible, right? I ideally want when a new Talos release comes out that I can rebase or merge, push, and have things, out and ready to flash and upgrade automatically, especially because building the Linux kernel can take a while, etc. So we're going to look at my Docker build system. before I go on, you have to promise not to freak out. I'm going to show you the diagrams. This is a little bit overwhelming. You don't need to understand. I'm not going to talk in detail, but I want to show you just kind of the parts that are coming in here, type of thing, is maybe your sort of worst case type of scenario. So this is the kernel build side. I hope that it is readable over the screen share. But we have kind of 3 Git repos that are coming in as Docker contexts and sources, and going through a bunch of stages, different things. I have in the middle you'll see a kernel build config. Because I have a generic pipeline that uses the stock kernel config, but then Talos, I have a custom config for Talos that has a bunch of Kubernetes options turned on that aren't in the upstream kernel config. We have kernel modules. I'm building the firmware. I'm not actually using it right now. But eventually we get out at all the way at the bottom there. We output a kernel in a Docker image. This is just sort of a data container that then gets used by the Talos installer, which is very similar. Again, if you the guide I had linked a couple of pages back, if you were building a custom kernel and that's all you needed, this would be the place to plug in. But this gives me a very nice setup, pulling together these multiple different repos of patches and overlays and device trees, and really getting them into a single unified part. You might notice that there's even a little SDK box up there at the beginning. That itself has its whole own other build process that is getting spit out at the bottom here. Again, just showing you there are a lot of moving parts in this ecosystem, and so having kind of this to pull it together is very, very helpful. Because then we also don't forget we have U-boot, similar type of thing. What's even going on here is that again, I've talked about kind of these forked off vendor versions and then mainline. So Collabora is hired to do the mainlining work. I think Radxa sponsors them, as well as other companies, Rockchip, et cetera. I'm not sure how it works. So U-boot is getting mainlined right now. So I've actually got things set up right now, building from a fork, so that I can start testing that better mainline support instead of the vendor one. And I want to show you kind of a little Docker file trick that came out of this, because I just terrified you with diagrams. This is sort of an interesting, little pattern that I used for multi-platform, where I actually wanted to be able to both build on, I want to be able to actually build everything on the Rock 5 itself on ARM, as well as do cross compiles from my, powerful desktop. So I actually have the case where I have slightly different things in the base image. So what I ended up doing is I have this common stage that's called SDK deps, but then I made ones off of that with an architecture suffix that's just a string. But then when I actually reference it later, I can use the built-in build architecture variable in Docker. So it'll resolve to the correct one. And so now, based on where I'm building, the build tree will get built up properly. Which is really nice, because I can now build, everywhere across. And I actually even have GitHub Actions with a self-hosted runner now set up, so that the entire thing, the whole system can build itself and maintain itself, which is, I think, pretty neat. So we're now pretty far off topic of where we were going, but we got the kernel and U-boot building. We have a Docker, a GitHub Actions pipeline that runs that Docker bake and publishes it. If you look carefully at the top there, you'll see that this job succeeded in 46 seconds, which is remarkably fast for a kernel build, because thankfully it's on a schedule where it'll pull down upstream changes, and there weren't upstream changes at this point. So the cached one got retagged and put out, and it was nice and fast. So great, that was easy. We're done, right? But nope, there's still always more. So let's talk about the Talos installer. You might have remembered I mentioned that whole thing about UEFI. So yeah, we don't have UEFI. I did try and recompile the version of U-boot that I got with UEFI enabled. That did not go well. There is also an in-progress port of EDK2, which is the reference UEFI implementation out there, but I actually have it building. It was not shown in those terrifying diagrams, but it's in there. But I haven't actually attempted it, because I decided I wanted to get something working. So I went for Linux, which I learned actually when preparing these slides in the past few days that this is actually a, I guess, return to Linux for Talos, because older versions before I started using it appear to have used Linux before they switched to UEFI and Grub. I wish I had realized that earlier, because I probably could have taken some code out of history. But for right now, I have a hard-coded boot file. It basically is, just pointing at a device overlay for this board and then the kernel image on the boot partition so that we can get everything booted. We don't have Grub, but that's okay for our purposes. I actually took out the EFI and BIOS partitions entirely, which is great, except that we do have one problem here, which is that Linux is going to boot the boot partition, which is XFS in Talos, and U-boot does not support that. So yes, we have added X4 support as well to Talos, but just for the boot partition. So where did this get us? Well, the good thing is we now have a boot process. And I don't know about you, but that's really all I care about from my bootloader, is that it boots. There are some ugly things there. I mentioned that was a static template, so we can't customize our kernel args. Because I removed the EFI partition, that's normally where your device overlay file lives, and then EFI can pass it to the kernel and do magic. I had to then instead put that on the boot partition for Linux to reference. So it's just another small installer tweak. I also did mess with the partition offset logic in Talos. This is something that I need to revisit and potentially open an issue for. I think that what Talos is doing right now is compliant, but maybe not common. And so I was having a little trouble with it and had to tweak things a bit. But again, I'm doing a lot of sketchy things. So little interlude here for kind of, talk about debugging. How did I even get to this point? I restarted a lot. I rebuilt a lot. I bought a USB debug cable, which I have here, that can plug into the GPIO headers and then give you the console output on the computer, which was invaluable, especially for early boot process issues. But overall, this was fairly tedious. I actually had a little bit of time off work at the end of last year. And so I spent the better part of a week, kind of on a lot of this, which was just a lot of build, wait for builds, flash, and come back and hope, and then maybe fix an issue. But I do again want to point out that this is all, I'm, trying to condense a bunch of stuff here and give you a little bit of a picture, but I am not a hardware developer. Again, I'm not embedded. The most I'd done was, set up Pi-hole on a Raspberry Pi before. So this was just a lot of, keeping at it, and doing it iteratively. And it's nice because, either it boots or it doesn't, and hopefully you get an error that helps you. It can kind of go back. So we then have the sort of the Talos user space part. So these were the other changes. These were just, more hacks that I needed. I'm not going to go through all of them. It was mostly a lot of deleting things from that Talos might normally enforce, because either they're not turned on in my kernel because I didn't find the option. My kernel doesn't even support it because it's an older 510 LTS that has interesting heritage. Or who knows? I wasn't that concerned right now. There's GitHub issues open for some of these for me to go back and look, but I just haven't had time. One of the fun ones that is crossed out is that originally the kernel refused to compile the Ethernet driver as a built-in, only as a module. Apparently, that's not something that Talos really expects for you to bring up the hardware the first time without an Ethernet driver. So I had to add a little bit of sneaky code to forcibly load this early in the process so that I could even join the board to my cluster. But thankfully, that got fixed in the kernel config, so everything works now. My kernel is also gigantic. I don't know why. I think it's just a bunch of drivers that are unnecessary. So it's about a gig on its own. So I had to increase Talos's assumption for how big some of the partitions are. Again, I have 64 gig cards. I'm not super concerned about the usage, but certainly could be optimized. And so kind of, the thing I want to do mention here is kind of the budget of this whole project from my side, to give you an idea of a little bit of transparency. Everything I'm going to show you can be found either at AllNet China or Ameridroid. I don't have any sort of deal with either of them. Those are just the two vendors that generally sell Radxa stuff. Ameridroid is, if you're in the US, they're in the US. They can have a little bit of lower costs, especially for shipping, but then their often item prices are higher. AllNet, you get lower item prices, but more expensive shipping. You're going to see prices here from AllNet as of today. Things will change, but I just want to give you an idea because some of this can be a little bit hard. I'm also pricing things out for a 3-node cluster, so get ready to see me spend a little bit of money. So here's what we've got for kind of what I have. I have 3 Rock 5s at 16 gigs each. Those are 190 retail right now. At AllNet, I got 3 metal cases, which I have a half assembled metal case here. It's a nice little metal case, and I'll show you a picture of the full thing in a second. Power adapters, storage, and then you'll see that kind of sticker shock on my shipping cost that came from AllNet because it does ship from China. It did ship fast. It came easily. And again, the prices actually kind of balance out based on wherever you buy them. And yeah, I also mentioned NVMe. So I also actually have SSDs in there as well, which adds another decent chunk. So yeah, I'm now up to about $1,200 for a very, very kitted out cluster. Yes, it's expensive. I don't want to discourage you with that. There is also a Model A variant coming out soon, which is a cheaper variant that cuts out some of the I/O. Again, you don't necessarily need SSDs here. You can just use the eMMC, for example, if you're not trying to do fancy storage stuff. You don't need cases. You don't need 3 of them. There's a lot of options here, one last note here about the reason there's a little scary warning next to the power supply is that there have been some reports. This board does use USB-C power delivery for power, and there's been some fun adventures there, I think, with people and compatibility with different adapters. So something to be aware of. I bought the official ones. They've been great for me. I haven't had issues, but some people have. So again, just trying to give some information in case you decide to pursue this path. And then here is a little picture of my cluster sitting on the desk. It's not pretty. We're going for authenticity here. This is not a fancy project, right? This is me at my house trying to get this working. Part of my motivation here was financially based because, as you saw, I ended up taking a pretty big gamble on this ecosystem and put a lot of money into the project. So I was quite motivated to get my fork working. And also, hopefully, it's clear why this is a fork right now, right? My ideal state is that all of this code starts slowly going away, and then there is more or less a single file PR to the upstream Talos repo to give you that board file. Everything just works in the future, but for right now, it's not really in a practical shape to upstream, given that I need to turn off certain security features. The kernel itself is not a mainline kernel or really close to it, again, which is I feel fine with for my home lab purposes, but you might not based on what you're doing. So there's research there, but now that it's been up, I also I'm not trying to scare you off here. My cluster has been running stable for a couple of months now. I think the first version I got up fully was 1.3.1. I've done upgrades across my 3 nodes between each Talos releases. I've done new ones without issues. It's been great. It's been super fast. The slides right now are running off of HedgeDoc on the cluster, across the room from me, and different things. So it's been a lot of fun. It's been great. The hardware is very great, very fast, very powerful. It's been fun to play with. And I recommend it if you're looking for an adventure. The boards are there. I know people are talking in the chat about like the Odroid. There's other options there. There's plenty of things, but if you're looking for a challenge and a fun adventure, or you want the crazy hardware, it's come hang out in GitHub and let's get more of these boards up. And I did really want to put one of these on Omni, but unfortunately, my hacky hard-coded kernel and then dying dev board really hampered me there for getting up in the global cluster. But yeah, I'm happy to. I was hoping to. I was hoping to take a couple minutes to boot this board up and join it into the cluster. Unfortunately, it did give up on me. But
Well,
I'm happy to answer your questions live now or here. Again, you can find me. I'm in the Talos community Slack. You can toot at me. I am on Twitter. I might look at it, but I don't really look at it very often anymore.
Yeah, super impressive. Yeah, all our engineers were chatting in the background. It's like, and you did all this without even asking questions in Slack.
I asked a couple questions, which were kind of, there were sometimes like, but yeah.
So your one that died is giving light the unbreakable argument. Although I guess it's physically unbreakable.
Yeah, so one of the neat things with these boards is that over the USB interface, there's a tool you can use to kind of, because there's a lot of shared Android heritage. So if you've done that, you can put it in a mode where you can flash it because it has an SPI chip, or you can even write to the eMMC over it. It is slower if you're flashing, a multi-gig image versus using like, a USB reader for the eMMC, but it is very convenient when you have things connected. And also that runs in its totally own, I guess it's all separated. So no matter what you do, basically flash to the SPI, you can always hit that button on the board and plug it back in and still get into that mode. And that is I even have a fully Dockerized weird version of that tool because it's saying you have to compile and got it all working that passes through the USB. So you can do everything without installing anything.
Nice. How much power do these computers draw?
It can go up. So I think, they can, if you load it up with accessories and SSDs and you put under power, you could probably get, I think, into the over 10, to 20 watts, or let's say. I don't think but under general thing, they're very efficient and very low. And, I think you're looking at, unfortunately, my kilowatt right now is plugged into my fridge. And so I haven't been able to use it to measure these boards directly, but they're with under 10 watts, even at pretty high load.
Awesome. Yeah, that was super impressive. Any other questions trickling in? Oh, Christoph says he's running a 3-node cluster of this, thanks to you. Nice.
Get more, yeah. And so yeah, they're good. Come hang out. Come get boards and file issues and fix things.
Awesome. Well, really appreciate the talk. That was super interesting. We are supposed to have a talk now from Brian, running Talos in Talos, although he's messaged me and said he's got some personal issues, and that's probably not going to happen. So I'll go check if his session's going to happen, but otherwise we might have a break until 15 after the hour when Andre's going to tell us. But maybe, yeah, Spencer's just slacking me and saying that we might just hang out in the session and do a Q&A if someone wants to ask any questions. So Spencer, Andre, and I, maybe Tim, maybe someone else, we'll go hang out in the running Talos in Talos session, and we'll just turn it into a general Q&A. Unless, of course, Brian shows up, which would be cool. But thanks very much, Miles. That was super cool.
Yeah, thank you, everyone.